Now, moving on, we can now talk about how to measure the performance of simulator and emulator tools and the various trade-offs between them. So there are three main metrics that can be used to describe our simulator or emulator tools. The first and most important is the error. This is the distance from the result to the expected results. So a simulated tool or design tool will have some result that it outputs, and that result may or may not be correct. It, in general, is going to be an approximation or estimation of the expected result. Now, understanding the distance between the result and the expected result is simply a metric of error that tells you how good your simulation output is. Now, in addition to error, there's also the latency. This is how long it takes you to produce a result from a query, and there's also the cost. This is how much money or power it takes to run the compute platform that you use to acquire the results. Note that these are all kind of interrelated metrics where latency might be decreased by increasing the cost, or error might be decreased by, once again, increasing the cost. So it's important to really investigate how these trade-offs kind of affect one another as we're looking at simulation and emulation tools. And the way that this works is we can improve any one of these metrics, but the other metrics are going to be affected. So if we wish to reduce the error in a simulator or emulation tool, well, that would typically require us to use less approximation, which would then increase either our latency or our cost of computing. Now, if we wish to reduce the latency in our tool, that would require us to use more approximation, which would lead to more error, or it would require us to use more compute power, which would increase the cost. Finally, if we want to reduce the cost of our simulator or emulator tool, it will require us to either use less compute power, which would essentially make us take longer in our latency, but would decrease the cost per second of running the simulation, or we would need to use more approximation, which would lead to more error, but would reduce the latency and the associated cost. So the main point to take away here is having a low cost, low latency, low error simulator is perhaps unreasonable, but we can optimize two of these parameters pretty well. So the main point is, as you look at your project that you might be using a simulation or emulation tool, you should really be considering the budget, timeline, and required accuracy. Since each simulator tool might not compare in its cost, latency, or error, you should be picking the tool that fits within the budget of your project. So the way that this analysis would be done is, first you would assess the accuracy, which is how much error can be tolerated in your design problem. This might not be the same in each case. Simpler problems might require or might allow for more error, or larger problems might require more compute cost to achieve a certain desired error. But at the end of the day, the accuracy that's needed is dependent on the application. Second, the timeline is how quickly you need to have results. So if you need to run many simulations, do you have enough time to run all of those simulations within the timeline of your project? So this is where the latency of simulation comes in. If you take the number of simulations you need to run and multiply it by the latency of each simulation, you would have the amount of time that you would spend running simulations for your project. This ought to be less than the timeline you have set aside for your project to be completed in. And finally, budget is the amount of money that is available for running simulations and emulations. Understanding the cost of running a simulator or emulator tool is important for identifying how much money or cost you will be using to run it. So not all simulators or emulators will be the same. So if you are comparing different tools, you should be comparing their error, cost, and latency so that you can make the right choice when selecting the appropriate tool.